Ladies and gentlemen, this is your well-rounded math teacher, Mr. Pickar, and we're working with piecewise functions today. This is Unit 2, Notes Video 6. What we want you to be able to do is, first of all, learning targets. I can graph the different sub-functions of a piecewise function, and I can identify domain and range of piece functions. So we're going to continue on with domain and range a little bit here. Okay, first of all, a piecewise function is a function which is defined by the subfunctions that each applies to a specific part of the domain, meaning that the graph is broken up into pieces. We're going to be graphing a couple different lines, but only a piece of each line. So when you have less than or greater than, you will have an open circle at a point. Now these are your end points or your starting points when you're graphing these lines. For example, your line might look like this. If it's less than or greater than, it's an open circle. If it's greater than or equal to or less than or equal to, it's going to be a closed circle. In other words, you have a circle there, but you're going to fill it in. That point is part of the graph itself. This point is just kind of like a starting point, I guess you call it. Okay, so we're going to get right to this and start graphing some of these functions. Okay, first one here, you have this f of x. It's just a function, and this is a piecewise function. You have 2x plus 1 if x is less than 0. This little part we call our constraint. It's a constraint. It's a starting point or a stopping point for the function itself. But this is the function that we're going to be working with. So I'm going to break this up into, it looks like there's two different functions here that we're going to graph. They have two different constraints. They deal both with 0, and I'll talk about that in a minute. F of x is the same thing as y, so I'm going to say y equals 2x plus 1. That's what I'm going to graph. If there are no constraints, I just graph this line. If x is less than 0. This is our constraint. What that means is it's kind of a starting and stopping point. Now, if you just looked at x equals 0, here's 0 on the x-axis. This is where our constraint lies right here. This side, all our x values are less than 0, so we'd be kind of looking at this constraint right here. This side is where x is less than 0. This side of the graph is where, now here our constraint for the second one is greater than or equal to, so I'm going to say x is greater than or equal to 0. So no matter what, if I graph a line, if I want less than 0, I would only want this part of the line. Okay? If I want greater than 0, well then I'd want this part of the line, because that's where you're dealing with all your x values that are greater than 0. So we need to graph this line. Y equals 2x plus 1, just using slope-intercept form. I'll graph this one. We'll graph this one in blue, I guess. My y-intercept is 1, right there. Slope is 2, so up 1, 2 over 1, 1, 2 over 1, or you can go down 1, 2, and back 1. So I'll kind of put a dotted line in there for right now. Okay? Now, that's what this line is right here. We don't want the whole thing. We only want this part of the line where all my x values are less than 0. Well, that would be this side going to the left. So we really don't need this part on the right-hand side. So I'm going to kind of get rid of that. It starts at 0, but we only want it when it's less than 0. So I'm just going to circle that and leave it open. And there it is. There's our line. That's what we're looking at for our first part of that piecewise function. I only want a little piece of the line. Now the second one here is y is equal to 2x minus 1 if x is greater than or equal to 0. So this should be on the other side of my x-axis here, going on the right-hand side. But we're going to graph it now. Slope is 2, y-intercept is negative 1. Negative 1 is right here. Slope is positive 2, so up 1, 2 over 1, up 1, 2 over 1, or down 1, 2, back 1. So they're kind of parallel, I guess you'd say. If you kind of put a little dotted line in there, it would look something like this. We only want it when x is greater than or equal to 0, right here. This is our constraint. So we want the, when it's going to the right and up, I guess you say. So I don't want this part of the line. Now, here it's greater than or equal to 0, so 0 is actually part of your graph. So I'm going to circle that and color it in and go up and to the right. So those are our two different graphs. That's our piecewise function. Domain and range. A couple things here. When you look at your constraints, they start and stop at 0. Here it's less than 0, but here it's greater than or equal to 0. All your values less than 0 are negative. All your values greater than or equal to 0 are positive. Basically, you're covering all the points that you would want to cover for x. There isn't any x values that are left out. This is going to be all reals. Another way to look at it is this. Here are your x values. Did we cover all the x values? Are there any left out? Well, right here in the middle at 0, here it's not equal to 0, but here it is equal to 0. Then you got -1, -2, -3. As I keep going down, and I'm actually going to the right for x, I'm eventually going to get to -infinity. As this graph goes up right here, you got 0 right here covered. 1, 2, 3, 4, 5, 6. It's eventually going to get to positive infinity for your x. So you can look at your graph also. If there's some missing spots in there, you'd have to be aware of that. But your range for this is all reals. I'm not going to say it's always going to be that way, but for the most part it is. Very rarely do you have x values excluded from your domain. Your range, now that's your y values going up and down, right here. Are there any not covered? Well, when you look at this green one first, it starts at -1. It goes to 0, 2, 2, 3, 4, 5. It keeps going up. It's eventually going to, as it goes up for your y values here, it's going to get to positive infinity. On the other one, they start at 1 and go down to 0, -1, -2, -3. It's eventually going to get to -infinity. So my range, there's no values that aren't covered here. It goes from positive infinity to -infinity. So I would say all reals for my range also. Okay. Example 2, very similar. You're graphing two different things. I'm going to break them up right away. F of x same as y. Y equals, the first thing equals is x plus 1 right here. If x is less than 1. So that's my constraint. It's at 1. The other graph that we're going to graph in a minute here is y equals -2x plus 4. If x, basically the opposite, is greater than or equal to 1. So here the 1 is my constraint, but it doesn't include it. Here the 1 is my constraint for x, and it does include it. So you could put a little dotted line in here if you wanted to at x equals 1. Here's my x-intercept of 1. One graph, we're going to take x is less than 1. Here's all my values on this side, less than 1. Everything going to this direction is x is greater than or equal to positive 1 for the other constraint right here. So graph your two lines and take what you need. The first one here, my slope is 1, mx plus b form, and my y-intercept is 1. So there's 1, slope is up 1 over 1. Kind of like that. Or down 1, back 1. I'm just going to put a dotted line in there for right now. Now, that's my line. If I didn't have a constraint, that would be my line. I'd just color it in and that'd be good. But the constraint is this. We only want this line when your x values are less than 1. Well, according to this constraint line here, we only want this side of the line. So I am going to, right at where x equals 1, put a circle. And there's my first part of my piecewise function. Now, for the other one here, we'll graph that in green. -2x plus 4. Well, my y-intercept is 4, and my slope is -2. Now that's -2 over 1, so down 2 over 1. I go down 2 over 1, and it's right there. Down 2 over 1, down 2 over 1. I'm going to kind of put a dotted line in there for right now. So that's interesting that it goes right in that hole where x was equal to 1. Now, our constraint here is we want all the values greater than or equal to 1. Well, it's right on that constraint line, I guess you'd call it. We don't want the values less than. We want the greater than. And 1 is part of the solution, it's part of the graph, so I'm going to color that in now. And that's what our graph would look like. The blue graph had an open end, and the green graph, it's filled in because it's greater than or equal to. So let's go down here, domain and range. Okay. Are there any x values that aren't covered? No. As this graph right here goes down, it's going to the left. As it goes down, it's at -2, -4, -6. It eventually will get to -infinity. It comes up to this point at 1. It was open on one graph but closed for the other, so 1 is included here. Here's 2, 3, 4. As it goes down, it'll get to 6, 7, 8. It'll get to positive infinity. So it's going both ways. This is all reals. Now, the range here is a little bit different. Range is going up and down, your y values. So if I'm looking at this graph, thinking of my y values going up and down, there's a y value at 2, but is there a y value at 3? No. Both of these graphs go down, so both of them get to -infinity as they go down. So it's covered to -infinity, but it never gets to 3. The highest it ever gets is y is equal to 2. Sorry, I put a 1 there. Y is equal to 2. That's the highest point. So it doesn't get to 3, so I just say my range is this. Y is greater than or equal to, because it's filled in right there, 2. That's my range. If you have problems with the range still and you have questions, just let me know. Come see me. Okay, this has 3 parts to it. First one, this fx is the same as y. Y equals 1/2, -1/2, x plus 3. If, and here's my constraint, x is less than 0. Now, this one, it's kind of got a little integral there between 0 and 3, and then this one is greater than or equal to 3. So there's 3 different parts to this graph. Let's just graph the first one. My constraint is at 0. Well, x equals 0 on the number line. X number line is right there. So basically, it's just up and down on the y-axis here. I'm going to graph this one. My y-intercept is 3, right there. And my slope is -1/2. Down 1 over 1, 2. Let's see if I can do this. Right about there. Or the opposite would be up 1, back 2. So here's my dotted line. Now, I only want this graph when my x values are less than 0. Well, if this is x equals 0 up here, less than 0, x is less than 0 is going to go to the left here. So I'm going to erase a piece of this here. 0 is not part of the solution because it's just less than. I'm going to circle that where my y-intercept was at 3. And there we go. There's the first piece of my graph. F of x or y equals 1. This is the constant function. If you look at this in slope-intercept form, it would be y equals 0x, because there is no slope, plus 1. So you have a y-intercept at 1, but your slope is 0, so that just means there's a flat line at y equals 1. So to graph these when it's just y, I'm going to go to 1 right here, and basically it's just a horizontal line. Doesn't matter what your x value is, y is always going to be equal 1. Now, here's the big deal. If 0 is less than or equal to x, and x is less than 3. All this is saying is your graph is going between the points 0 and 3 for x. So here's x equals 0. 1, 2, 3. I'm just going to put a dotted line here at 3, and we only want the graph that's between 3 and 0. So right there. Now, here that's basically x is greater than or equal to 0, so it is going to the right here from that point. It's less than or equal to or greater than or equal to, whichever way you want to look at it, so I'm going to color that circle in. But at 3, it's just less than 3 right here. So that's open-ended. So that's how you graph that bad boy. Last one we're going to do in red here. Y equals negative x minus 1 if, just one constraint here, x is greater than or equal to 3. So this line right here is x equals 3. We want greater than or equal to 3, so we want to go to the right. 4, 5, and 6 are the x values that are greater than 3. So this is x is greater than or equal to 3. Okay. We get rid of this for right now so we can graph this actually. It's in red. Our y-intercept is -1. Slope is -1, so down 1 over 1. I don't want this whole thing. I basically just want the right-hand side because all your values have to be greater than or equal to 3. And that is right here at this point, so I'm going to circle that and color it in, and I'm going down and to the right. So, kind of moving this a little bit, and clearing this off. This is what your graph is, basically. Those 3 pieces. Talking about domain and range, this is going to be a little bit different now. First of all, my x values. Well, if you look at this line, as it goes up, it's hitting all my negatives for x. We're just talking about domain values, x going left and right. It's eventually going to get to negative infinity. But it stops at 0 right here. But here, 0 is picked up by the green little chunk of the graph and goes to 3. It doesn't cover 3, but this graph covers 3. And 4 is right here, 5, 6. As it's going down, it's eventually going to get to positive infinity. So basically all my domain values are covered. This is all reals. But x, not the same. I'm sorry, y isn't the same. If you look at your y values are going up and down now. So we're looking at this. Are all these values of y covered? Well, as this one goes up, it gets to positive infinity. So this is covered. As it comes down, though, it gets to 3. And between 2 and 3, this little area right there, there's no graph, so that's not covered. So, like 2, there's no y value of 2. So the first thing I'd say is this, just looking at the blue, it starts at 3 right here, and then goes up. So I'd say y is greater than, not greater than or equal to, just greater than 3. So there's this little jump between 3 and 1. This green graph, all my y values are equal to 1. So I'm just going to say this, part of my domain, or I'm sorry, range, is y equals 1. All these points on here, y is equal to 1. Then it jumps down from 1 down to, it looks like, -4. So there's nothing between 1 and -4. But it does pick up right here at -4. There's -6, there's -8. It keeps going down. It will get to negative infinity for the y. So the last little piece of this for your range, that you'd say y is less than or equal to, because it's going down here, 4. I'm sorry, -4. So a little bit with domain and range there. We're going to break this video up into 2 pieces. If I were you, I'd go and try and graph some of these piecewise functions. If you have problems, definitely come up and ask questions. But stay tuned for the next video. Peace out, and Girl Scout.